Good morning, ladies and gentlemen. My name is Gordon Zulu. So with us today, we are going to discuss about the applications of differentiation under calculus. So the applications of differentiation, we have increasing or decreasing functions, concave up or down, maximum or minimum, and the points of inflection. So we'll firstly start by defining what these are. We know to say the maximum point is the highest point on the curve within the given range, while the minimum would be the lowest point on the curve. The other point in hand is the inflection points, that are points which change the function's concavity. And we have the decreasing or increasing, which is explained as increasing is where the function has a positive slope, while the decreasing is where the function has a negative slope. So with us, we have one example to cater all these applications of calculus, that is increasing, decreasing, concave up or down, maximum or minimum, together with the points of inflection. But to start with, for you to answer this part, you need to find what are called the critical values, where the critical values are always founded by equating the first derivative equal to 0. So with us, we have that function. So the function is equal to 2x to the power 3 plus 3x squared minus 36x. So let's use this function in solving the critical points. So follow me closely. We will use the power rule for us to differentiate that function. So let us find the critical values. We know to say, for you to find the critical values, we will term this to be the first function, which is the f prime of x, which means dy dx. So we know to say the derivative of 2x to the power 3 is 6x squared. We just multiply 3 times 2, that is 6. Then we reduce the power by 1. 2 times 3, that is 6x. And we know to say the derivative of 36x is 36. Then for us to find the critical values, you equate this equal to 0 is equal to 6x to the power 2 plus 6x minus 36. Then we know to say there is a common number throughout. That number is 6, so that we leave our function in its lowest term. So we divide here, we will have our answer to be x squared plus 6 minus 6. Then from here we can use the quadratic factorizations method, where we have product, sum, and factor, where the product is -6, the sum is 1. And you look for two numbers which when you multiply, they will give you -6, and when you add those two numbers, they will give you 1. And those two numbers are 3, -2. So from here now, these two factors will replace this one. So we will have x squared plus 3x minus 2x minus 6, where we will now factorize, giving us x plus 3 minus 2x plus 3 equal to 0. So we will have x minus 2, x plus 3 equal to 0. We are interested in finding the value for x, so it will be x is equal to 3 and x is equal to 2. Remember, this positive will change to negative. So for us to know whether a function is increasing or decreasing, we'll draw a number line where we'll have intervals for these two critical values, where we'll put our -3 here and our 2 here, where x will say it is less than -3, and this x is between -3 and 2, and this x is greater than 2. So you will look for a number which is less than -3, and that number is -4. So that number being -4, you put it in the differentiated function. So the purpose of us putting the -4 in the differentiated function is for us to determine the sign, because it is the sign that will tell us if it is increasing or decreasing. If it is positive, then the value is increasing, and if it's negative, then it is decreasing. So for here we have chosen -4. For here a number will choose 0, and for here we can choose 3. Then let's replace these three numbers in this function in here, which is the first derivative. So when we replace in our differentiated function with -4, the value is 36, and you know to say by virtue of you seeing a number without any sign, we know to say it is what? Positive. Here we have it to be negative, so which means here it is increasing. Here it is decreasing, and here it is increasing. So this is how we determine whether a function is increasing, decreasing, and increasing. So aside from this, you can also use the same critical values to finding the minimum or the maximum. How do you do this now? You get these two values you had found. You put them in the original. Take note. You put them in the original. Yes, I know to say we can find the minimum by either using the first derivative or using the second derivative. But with me, I will concentrate on using both so that we avoid questions to ask, why can you not use this one, or why can you use this one? So I want to prove a point. If you use 2, if 2 becomes the minimum or the maximum, let it be so. We don't want 2 to be both the minimum or the maximum. So we put these 2 in this function. So we will have f of 2 is equal to 2 to the power 3 plus 3, 2 minus 36, 2. Then we have f of -3, 2 -3 to the power 3 plus 3 -3 squared minus 36 minus 3. So when you punch on your calculator, the values you get are, the values that you will get are -44 and 81. So this one, remember it is small, so this one is the minimum and this one is the maximum. So this is how you determine the minimum or the maximum using first derivative. Let's now use the second derivative in determining if a function is minimum or maximum. So remember we used 2 to determine whether the function is what? Minimum. So this same 2 we have used, let it also be called the minimum in the second derivative. Let's see how this function will be. So remember this is our first derivative function, so we'll put f double prime, meaning second derivative. It will be 12x plus 6. So now what we do here is something that is very simple. You now get those values you had found called the critical values. Remember, we had found the critical values being 2 and being -3, where we said in the first derivative, this one was the minimum and this one was the maximum. This is under the first derivative. So now you will get these 2 and put it in here. So you have f double prime 12 plus 6, which is 24, plus 6 giving you a 30. And when you put this -3, f double prime is equal to 12 -3 plus 6, giving you -36 plus 6, where this one is -30, while this one in second derivative is what is referred to as the minimum when it is positive, and when it's negative is what is referred to as the maximum. The result is still the same. The computation is what is just different. Why? Because someone would prefer to use the first derivative and someone would prefer to use the second derivative. So please note, when you are using the first derivative in getting whether it is minimum or maximum, you use the original function. If it is the second derivative, you get those critical values, you put them in the double primes function. So from here now, we can determine the concavity of a function, whether it is up or down. By how do you do that now? You get this function, the second derivative, you equate it to 0. Then we will have 12x plus 6. So remember, you want to determine whether a function it is concave up or down. You will equate this equal to 0. So you will have this equal to 0 now. Then you will have -6, divide both sides by 12. You will get your answer to be -1/2. So having gotten our answer to be -1/2. We will now draw a number line where you will plot this -1/2. You will have this side and this side. Where this side you can pick any value. Remember, this is the negative side of the number line and this is the positive side of the number line. So let us pick a number this side. We can pick a number 0. So if you put this 0 in here, you will get the function to be 0 plus that. So it will be 0 plus 6, which is equal to 0. So since this is positive, then it is concave up. Then you get any number again this side. Let us get even -2. So we get -2. If you put the -2 here, you will have 12, -2 plus 6. Then here you will have -24 plus 6. What is -24 plus 6? That is -18. So since this is negative, then it will be concave down. Then, for you now to find the points of inflection, you will find the points of inflection by getting this value you are from finding, you replace it in the original function. In this case, the original function is this one. Is this one, the one we had found, -36. Then you put that -1/2 in here. So, in short, you are looking for the y value. So -1/2. Remember, we said the points of inflection is where it changes concavity. So we know to say here we will have 2 -1/8 minus 3/2. Sorry, here there is a squared. So we'll get positive 3/4 minus, which will go to a positive, which is 18. Then 2 times that one, it will give us -1/4 plus 3/4 plus 18, where you can just punch that directly on your calculator. So immediately you punch that directly on your calculator, it will give you 18.5. It will give you 18.5. So since it has given you 18.5, then the point of inflection is -1/2, 18.5. So if there is any question in determining the concavity of any exponential function, logarithmic function, please just do them the same, but I will drop videos in how we differentiate exponential function together with logarithmic function. Your host signing out, Gordon Zulu. Remember to like, share, and subscribe.